Another characteristic of compounds for which we can solve using Raoults' law is molar mass. It turns out if we very carefully design our experiment, we can use the vapor pressure that we calculate for the solution to determine the molar mass of the solute that we actually added to the solution. In this particular question, it says at a certain temperature the vapor pressure of pure benzene is 0.930 atmospheres. We then add some unknown solute to it, 10 grams of it. We know the mass of benzene to which we added the 10 grams of the non-volatile solute. We then measure the new vapor pressure of 0.901 atmospheres. So knowing this information plus the mass of the solute and the solvent, we can actually solve for the molar mass of the solute. This is how it would be done. First, we would solve for the mole fraction of benzene using Raoults' law. The mole fraction then is going to be equal to the vapor pressure of the solution over the vapor pressure of pure benzene. We get 0.9688. We know that the mole fraction of benzene is equal to the moles of benzene divided by moles of benzene plus moles of solute. So now we can solve for the moles of benzene by knowing the mass of benzene. We get exactly 1 mole of benzene. So the 0.9688, which is the mole fraction benzene, is equal to 1 over 1 plus the moles of solute. So although moles of solute does not give us the molar mass of solute, it gets us a lot closer to calculating this value. So we'll go ahead and solve for the moles of solute, and we get 0.03219 moles of the solute. Now if you remember, molar mass is defined as grams of the substance over moles of the substance. So all we need to do is take the grams of the solute and divide it by the new moles of solute that we just calculated. The grams of solute was given to us as 10 grams. The moles of solute we just calculated. If we divide those two numbers, we can get the molar mass of the solute. The key to this problem is really knowing the definition of molar mass. There will be other colligative property type calculations where you will determine the molar mass, and knowing this definition will be very helpful as we proceed in this chapter.